Hello everyone and welcome to the video note for exercise 5.14. In this video we're going to write a method that calculates pi. So we're going to have a method and it's going to return a double which contains the value of pi. Now our method is also going to have a parameter which limits the precision of the return value. For example, if we only need pi down to 2 decimal places, then we can pass in a parameter which limits that to 2. Or if we need a very high precision value for pi, we can pass in a larger number. So with that, let's get started. Over in Eclipse, I've created a new project called exercise 5.14, and to this we're going to add a new class, which is also going to be called exercise 5_14. Remember the naming scheme that I'm using for these exercise videos. Okay, so the first thing we're going to do is start off writing our method. Now this is going to be public static double, so it's a public static method. It returns a double and we'll call this m, and it passes in a parameter which is an integer called n. Okay, so in here what we're going to do is declare two variables. The first one is going to be a double and it's going to be called pi. And to start off with, it's going to be equal to 0. The next is going to be term, so double term, which we won't give a value just yet. Now, we're going to calculate pi here using a for loop. So for int I equals 1, I less than or equal to n, I plus equals 2. So what we're going to do inside here is calculate a term, and the way we're going to do this is like this. Term equals 4.0 multiplied, now in parentheses now, 1.0 divided by, more parentheses, 2 multiplied by I minus 1. Now, in the outer set of parentheses still, minus 1.0 divided by another set of parentheses, 2 multiplied by I plus 1, and then a semicolon at the end. What we're going to do next is simply pi plus equals term. Now, if you're not familiar with this method of calculating pi, the best place I can suggest you look is either in the book or Wikipedia, as normal. It's a source of all knowledge. So, anyway, at the end of this method, we obviously need to return a number. So we will return pi. And that's it. That's how. That's a method that we can use to calculate pi if for some reason we need to do this ourselves, instead of using math.py, for example. Now, why don't we test this? So let's create a main method. Public static void main string array args. Now what we might do here is have a loop that generates pi to higher and higher precision. So system.out.println I/t/t m I. So you'll see how we're using two tabs here to separate I, the term, from whatever we calculate pi to be. So for int I equals 10, I less than or equal to 100, I plus equals 10. System.out.println I plus two tabs mi. So inside our loop, we're calling the method to calculate pi. So you can see here we're doing this 10 times. Each time we're making I, the parameter we pass into this method, 10 units bigger. We're incrementing it by 10 each time through the loop. So with that, let's print this and see what happens. Sorry, run this and see what happens. Run as Java application. And you can see here what's going on. If I make so when I equals 10, we have 3.04, which isn't really that close to pi. But as we make this bigger, we get a better approximation of what pi is. So if we made this 1000, you can see we're starting to get closer. 3.14. If we made this 10,000, we have 3.141, which is getting closer to pi. So you can see here, with smaller values of I that we're passing in as a parameter, we don't really get a very close approximation of pi, because we're only adding term onto the value so many times. The more often we add this, the higher our precision gets. But anyway, we've created a method that can calculate pi down to various precision depending on what we want. So with that, let's have a quick summarize. We wrote a method that calculates pi to a certain precision. Now the method returned a double, and it passed in a parameter which set the required precision that we needed. Now remember, when this was a low value, we didn't get a very close approximation of pi. 3.0 isn't that close, when what we really want is 3.14 something. But it gives you an idea of how we can create a method to do something important that we can use over and over again. So with that, that's it for this video. Thanks a lot.